Hi grade 11, so glad you could join us, and today what we are going to be doing is following on our circle geometry revision. We're going to look at a few questions. Hopefully you've had time to practice these questions and to make sure you understand these concepts. We're going to be clearing up some of the problems that learners generally have in interpreting circle geometry diagrams. Of course, once again, just to remind you guys, it's so important to revise circle geometry for grade 12 because there's an entire section in your paper 2 exam that's based just on circle geometry questions, okay? And of course, you can use circle geometry when you start doing similarity of triangles at the end of the year, equiangular triangles and all of those things. You need to remember your circle geometry because they can, those triangles can fall within circles as well. Okay, so question 1. We are told that in the circle centered O, with center O, the radius is 10 units. So let's mark off here our radius. They've said here, we can already see that we've got one point there as 10. If I were to extend OQ until it reaches the circumference, so continue that line, then that would also be 10 units. Of course, if I join point O to P and then O to R, those are also radii, so they are all 10 units as well. Okay. They tell us that OQ is perpendicular to PR. Now that's an important theorem because remember, one of the first theorems you learn in geometry, in circle geometry, is that the line from the center of the circle is perpendicular to the chord. It then bisects the chord at the point of contact. So since we've got this line from the center of the circle, so this line OQ being perpendicular to PR, that tells me that PQ must be equal to QR, and the reason for that is line from center theorem. Okay? They've told you that the length of PR is 8, and because of that line from center theorem, what that means is that this point Q is the midpoint of the line PR. So therefore PQ would be a half of 8, so it's going to be 4 units, and QR is going to be a half of 8, so it's also 4 units. And they ask you to determine the value of x. Well, once we've listed all that information based on the given information from the question, you can see that it becomes quite easy, hopefully, it becomes quite easy to see how we're going to calculate the value of x. How do we do it? Well, we can see that if either we choose to use triangle POQ or triangle QOR, we've got triangles with 90 degrees in them. Okay, that's important because that then gives us this other theorem we can use. Can you remember the name of the theorem? Hopefully you all remember, it's called Pythagoras. Because I've got a 90-degree triangle, I can use Pythagoras theorem to help me work out the value of x. Okay, so what do we say? Remember, we've got to first say that OR is equal to 10, and the reason for that is that it's the radius. Okay, we also know that QR is equal to 4. How do we know that? It's the line from center theorem. All right, and what else do we know? They told us that OQ was equal to x. That was given. So I can say that PQ is perpendicular to OQ because that was given. They told you so. So therefore, in triangle QOR or OQR, it doesn't really matter what order you use. We can say by Pythagoras, we've got that OR squared is equal to OQ squared plus QR squared. So OR squared is equal to OQ squared plus, it was QR squared. Now we know that OR is 10 units, so I can substitute that. We know that QR is 4 units, I can substitute that, and OQ was x. So therefore, OQ squared, remember your reason for this statement before was Pythagoras. So therefore, OQ squared is going to be equal to OR squared, which is 10 squared, minus QR squared, which is 4 squared. So it's 100 minus 16, which is 84. So therefore, OQ squared is 84, and therefore OQ will be the square root of 84. All right. Okay, guys, so this is just a straightforward application of the line from center theorem. But what is tricky about this is if we go back and look at the diagram and where learners get confused and where you need to be aware as well is how to get to the value of OQ by realizing that OR can be extended and then OP so that those are your radii. When you don't realize that, it becomes really difficult to see how you can use the given information to help you work out the length of x. Of course, here we also need to remember that if the line from the center of the circle is perpendicular to the chord, it bisects the chord. So those are a few things that if we forget about, it makes it tricky. It makes it really difficult to answer a question like question 1. Okay, let's have a look at question 2. So still staying with Pythagoras. They tell us that LK and LM are tangents to the circle. Straight away, LK, LM, what do you see? You've got that this L is repeated. That means these are tangents from the common point L. So we know there's a theorem that says that tangents from a common point are equal, so therefore LK must be equal to LM. You can see on the diagram that they've written that LK is 6 centimeters, which means LM must also be 6 centimeters. All right. And so LM is 6 centimeters, LK is 6 centimeters. They've told you that O is the center of the circle. We know that the line from the center, which is called the radius, is perpendicular to the tangent at the point of contact. So the line from the center of the circle to the circumference, which we know is called the radius, that is then going to be perpendicular to LK, and then similarly OM will be perpendicular to LM. They've told you that the whole length LN is 7.5 centimeters, and by using tangents from a common point, we've shown that LM is 6, so therefore MN must be 1.5, because that whole length from L to N is 7.5. 7.5 minus 6 gives me 1.5. They ask us to find the value of E. Okay, so that's the length ON. Now you can see that that length ON extends beyond the circle. It doesn't matter though, because we know that OM is perpendicular to LN because the radius is perpendicular to the tangent. So this means I get a 90-degree triangle OMN, and that means I can use Pythagoras, if I've got enough information, to work out the length of ON. So we know that OM is also the radius of the circle. It's drawn from the center to a point in the circumference. So therefore, OM is going to be 2 centimeters. We know that MN is 1.5 centimeters. So therefore, to find E, which is the hypotenuse of triangle OMN, we can say that ON squared is equal to OM squared plus MN squared. So now, I'm just writing the final part of this out because obviously in this type of session we are pressed for time. You've got to go ahead and say all of the other stuff I've already mentioned on the diagram. So you need to tell the examiner why it is that MN is equal to 1.5. So you will say LM is equal to LK is equal to 6 centimeters tangents from a common point. You will say that LN is equal to 7.5, that was given. So therefore MN must be 7.5 minus 6, so it must be 1.5. Please do make those statements. You also need to state that OM is perpendicular to LM because tangent is perpendicular to radius. Please make those statements before getting to the point where I'm now writing the solution down. Okay, so ON squared is equal to OM squared, which was 2 squared, plus, let's show you the diagram, MN squared, which we said is 1.5 squared. And the reason for that is Pythagoras, but we can only get to this point. Remember, there's a whole lot of stuff missing. You need to give all those other points to show how we got to this point here. And remember, ON was x, So we get 4 plus 1.5 squared, so that's 3 over 2 squared, which is 9 over 4. In fact, let's do this on our calculator so that we don't make any careless mistakes. So we're going to have 4 squared plus 3 over 2, which is 1.5 squared. And that gives me, I've gone and done something silly, it was actually 2 squared, hey, which is 4. So it's 4 plus 3 over 2, or 9 over 4 squared. 3 over 2 squared gives me 9 over 4. In fact, I would be quicker doing this without the calculator, it seems, plus 9 over 4. That gives me 25 over 4. So 25 over 4 is x squared, so therefore x will be the square root of 25 over 4, which is 5 over 2. Of course, we can't accept the negative square root because length is never negative, so therefore x is 2.5 centimeters. All right. Okay, guys, I think at this point, let's take a quick break. You can go through, check my calculations, make sure you understand how to write all the steps for the rest of this proof. We'll be back after this.